Hello students, welcome to memoneet. This is Ravikant, your physics teacher. Hope you all are doing well. And today we are going to discuss the question paper of PPT 17. So the very first question of this question paper is that if two sources are coherent, then the phase difference between the wave produced by them at any point. So if the two sources are coherent, then the phase difference between the two waves emitted from the two sources have the constant phase difference, right? And because they have constant phase difference, the position of maxima and minima will be stable. So let's see what the option says. Option says that the first option says that the what coherent, then the phase difference between the wave produced by them will change with time, and we will observe stable position of maxima and minima. So first option is not correct. Will not change with time, yes, and will observe unstable position, no. Option 3 says that will not change, that is the phase will not change with time, right, and we will observe stable position of maximum minima, right. So the correct answer for question number 1 is option 3, that is, if the two sources are coherent, then the phase difference between the wave produced by them at any point will not change with time, and we will observe stable position of maxima and minima, right. Now let's see question number 2. Question number 2 says that an unpolarized light is incident upon a glass plate of refractive index 1.48 at Brewster's angle and get completely plane polarized. The angle of polarization is, so in this case the angle of polarization IP is given as tan inverse of refractive index of the surface through which, or the denser medium, refractive index of the denser medium in which the refraction is taking place. So here the refractive index is 1.48, so directly we can put the value and get the answer, that is the angle of polarization IP will be equals to tan inverse 1.48. So the correct answer is option 1. So the correct answer for question number 2 is option 1, that is IP, that is angle of polarization, is equals to tan inverse 1.48. Now let's come to question number 3. Question number 3 says that two coherent lights of intensities I and 4I are superimposed. The difference between the maximum and minimum intensity at interference pattern is, right. So the maximum intensity I max is equals to your A1 plus A2 whole square, and your I minimum is equals to your A1 minus A2 whole square, right. And what is A1, A2? A1 is the amplitude, so A1 is related to your intensity of the first source as under root of I1, and similarly A2 will be equals to under root of I2, right. So here in this question, A1 will be written as under root I, and A2 will be written as 2 root I, right. So using these values and solving, here we can see that I max will be equals to your root I plus 2 root I whole square, right, and I minimum will be equals to root I minus 2 root I whole square. Then your I max minus I minimum will be equals to, solving this we will get 8I, right, 8I. You can solve this and you will see that its answer will be equals to 8I. So the correct answer, correct answer for this question is option 8I. 8I is option 2. Correct answer is option 2, right. So next, coming to question number 4. Question number 4 says that in placing a thin sheet of mica of thickness 12 into 10 to the power of minus 5 centimeter in the path of one of the interfering beam in Young's double slit experiment, the central fringe shifts equal to the fringe width. Alright. Then the refractive index of the mica, if lambda is equals to 600 nanometer. Right. So the shift because of placing any transparent medium in the path of one of the wave is given as, shift is given as your mu minus 1 into t into d, that is distance between the slits and the screen, upon small d, that is distance between the two slits. This is the shift. This is the formula for the shift. And according to the question, the shift is equal to the fringe width, and fringe width is given as lambda d by d. So this d by d from this side cancels out with this d by d on this side. So what we are left with is your mu minus 1 into t is equals to lambda, right? So what we need to calculate is the refractive index. So this will be equals to mu minus 1 is equals to lambda upon t, and your mu will be equals to lambda upon t plus 1. So putting lambda as 600 nanometer upon t is 12 into 10 to the power of minus 7 plus 1. Solving this, we will get mu is equals to 1.5, right? So refractive index will be equals to 1.5. This is the formula where we will put the values. Value of lambda has been given in the question, value of t has been given in the question. Solving this, we will get mu is equals to 1.5. That is, correct answer for question number 4 is option number 1, right? Now let's move to question number 5. Question number 5 says that in Fraunhofer diffraction from a single slit, wavefront incident on the slit is, yes, it's the wavefront incident on the slit is the planar, right? It's a planar wavefront, right? So this you have to, if you have studied the experiment, you can see from there still it's a planar what's planar wavefront, right? So the correct answer for question number 5 is option 1. Yeah, you can see from this diagram, this Fraunhofer, this is the diagram for the Fraunhofer's diffraction. So here the beams are traveling parallel to each other. So the wavefront for this beam will be equal, it will be a planar wavefront, right? So now next, coming to question number 6. Question number 6 says that the Brewster's angle in air to water, Brewster's angle to from air to water transmission is. Now if refractive index from air to water is 4 by 3, then the Brewster's angle, that is IP, will be equals to your tan inverse 4 by 3, right? But in the option there is tan inverse 3 by 4, but there is also cot inverse 3 by 4. So if IP is equals to tan inverse 4 by 3, so in terms of cot, it can be written as cot inverse 3 by 4, right? So the correct answer for question number 6 is option 4. So it's on direct formula, that is your angle of polarization IP is equals to tan inverse your refractive index. Refractive index given as 3 by 4. So because they are wanting the answer in cots, so it will be equals to IP is equals to cot inverse 3 by 4. So the correct answer for question number 6 is option 4, right? Now let's come to question number 7. Question number 7 says that the interference pattern is obtained with two coherent light sources of amplitude n square, amplitude ratio n square. In the interference pattern, the ratio of I max plus I minimum upon I max minus I minimum, right? So the ratio is n square. It means your I1 upon I2 is equals to n square. From here we can say that I1 is equals to n square times of I2, right? I1 is n square times of I2. Now see, here we can see the calculations that I1 upon I2 is equals to n square. So I1 is equals to n square up into I2. Now I maximum is equals to under root of I1 plus under root of I2, as I told you in the previous questions also, right? That I maximum is equals to under root of I1 plus under root of I2 whole square. So putting the values here, we get I maximum is equals to I2 into n square plus 1 whole square. Whereas I maximum, I minimum will be equals to your under root I1 minus under root I2 whole square. It's not written here, it will be whole square, right? So putting the values, we finally get your I minimum is equals to N2 into I minimum is equals to I2 into under root of N2 square minus 1 whole square, right? So in the question they are asking you the ratio of I maximum plus I minimum into I maximum minus I minimum. So I maximum plus I minimum, this is value of I maximum, this is value of I minimum, again this is value of I maximum and this is value of I minimum. Solving this, finally we get it as n square plus 1 upon 2n. n square upon n square plus 1 upon 2n. So the correct answer for this is n square 1 upon 2n. Correct answer for question number 7 is option 2, right? So what is I maximum we are getting? I maximum we are getting it as I2 into n under root of n square, right? And under root of n square is nothing but n. We leave it as it is, and minus 1 whole square, right? Yeah, plus 1. And in minimum we are getting it as I minimum is equals to I2 into under root of n square minus 1 whole square, right? So the ratio they are asking is I minimum, I maximum plus I minimum, that is a plus b whole square plus a minus b whole square. So it is equals to 2 times of your a square n square का whole square plus 1 square, right? That is your, what we have used over here is, that is a plus b का whole square plus a minus b का whole square is equals to 2 times of a square plus b square, right? Using this we get I maximum is equals to 2 times of n square plus 1, right? On the other hand, using a plus b whole square minus a minus b whole square is equals to 4ab. Using this we get I maximum minus I minimum is equals to 4ab. We get 4n into 1. Solving this we get I maximum plus I minimum upon I maximum minus I minimum as n square plus 1 upon 2n, which is your option 2 in question number 7, right? Now coming to question number 8, coming to question number 8. Question number 8 says that two polarides are placed such that their planes are parallel to each other with their axis of transmission at 30 degrees, right? If an unpolarized light of intensity I0 is incident on first polarizer, then the intensity of light that will be transmitted through the second polaroid is. So if the unpolarized light is passed through a polaroid, its intensity will become half. So I1 is equals to I0 by 2, where I1 is the intensity we are getting as an output from the first polaroid. So I1 is equals to I0 by 2 with vibration parallel to the axis of the P1. P1 is the polaroid one. Now this light will pass through the second polaroid P2, whose axis is inclined at an angle of 30 degree to the axis of P1, and hence the vibration I1, right? So because the second polaroid is at an angle of 30 degrees, that the axis of the second polaroid is at angle of 30 degrees with the axis of the polaroid 1, therefore it will be with an angle of 30 degrees with the intensity of the, or the vibration of the output of the polaroid 1, right? So in accordance to the Mallows law, the intensity light emerging from second polaroid will be given using the formula, that is I2 is equals to I1 into cos square theta. The theta here is 30 degrees. So putting the values, we get I2 is equals to I1 is equals to I 0 by 2. So we put I1 is equals to I 0 by 2 into cos 30 ka square. So cos 30 is root 3 by 2. Its square will be equals to, and solving this we'll get I2 is equals to 3 by 8 I 0, right? 3 by 8 I 0. So the correct answer for question number 8 is your option 4. Option 4. So point which you are supposed to remember here is this point is important, that whenever an unpolarized light is passed through the polaroid, its intensity will become half. All right, its intensity will become half. And when then two polarides are at some angle, then you have to use the Malus law, which says intensity at output is equals to input intensity into cos square theta, right? Input intensity I naught, right? We can write it as I naught. This is Malus law. Using this, we get the final answer as your 3 by 8 I naught. So the correct answer is option 4. Now coming to question number 9. Question number 9 says, that the colors appear on a tip, a thin soap film and a soap bubble due to the phenomena of, right? So it's interference or dispersion or refraction or diffraction, right? So it's basically because of dispersion of the light, right? No, yeah, it's because of the interference, right? Because the lights coming from inside, they get, it's a white light, right? It's a white light. So when it moves outwards, there is a path difference between the refracted lights, and when they interfere with each other, they forms the, see, this is like a interference pattern formed because of the white light. This is the interference pattern. यार ये गड़बड़ हो गया, देखना पड़ जाएगा, बात नहीं कर सकते ना। अरे भगवान, हे ईश्वर।